Have you ever glanced at a block of code and thought it looked like some kind of secret language? Well, today, we're going to decode one together. We're going to find out how a few simple instructions can spark a whole conversation with your computer.
All right, take a look at this. I know it might seem a little complex, but it's not magic, I promise. All this program does is ask for your name and then say hello back to you. That's it. It's a simple conversation, and we're about to see exactly how it works.
But that's the big question, right? How do these symbols and words actually make that conversation happen? We're going to unbox this code piece by piece and find out. Think about it. To have any conversation, you need to remember things. If I ask for your name, I have to be able to hold on to that piece of information for a second so I can use it. And you know what? A computer's no different.
So just like our brains have short-term memory, a computer needs a place where it can temporarily stash information. This is its working memory, and it's exactly where our little program is going to keep track of things, like your name.
In the world of programming, we call these little memory spots variables. You can just think of them as individual boxes inside the computer's memory, each one with a unique label so we can find it again later. An even better way to picture this is as a simple labeled box, right? You create a box, you slap a label on it, and now it's all set and ready to hold whatever piece of info you need to store. Okay, so let's tie this right back to our code. When the computer sees the line string name, it's just following our instructions. It's literally saying, okay, got it, create one empty box and label it name. It's really that straightforward. Now, you can't just label your boxes anything you want. There are a few simple rules. The name has to start with a letter, and you can't use special words that C++ has already reserved for its own commands. But other than that, you've got a lot of freedom. Here's where it gets really interesting. That label, let's say A, can mean two different things. If you see it on the right side of an equal sign, it means give me the stuff inside the box. But on the left side, it means I'm talking about the box itself. So a line like A equals A plus 1 is an instruction that says, take the value out of box A, add 1 to it, and then store that new result right back in box A. So, okay, we've got a labeled box. That's a huge step. But what kind of stuff can we actually put in it? A number? A word? Maybe just a single letter? Let's go back to our code and see what's happening. See that word string right before our label name? That's the answer. That one word tells the computer, hey, this box I'm making, it's specifically built to hold text. In programming, we call this the variable's type. And of course, there are boxes for all sorts of information. You've got int for whole numbers, double for numbers with decimals, char for just a single character, and even bool for simple true or false values. A big part of programming is just picking the right type of box for the job. Okay, so we now know how the program can remember things. But how do we actually get the information into those boxes in the first place, and then get it back out? How do we have the actual conversation? Well, for that, C++ gives us two main tools. First, there's cout, which is short for character output. This is how the program talks. It sends text out to your screen. And then you have cin for character input, which is how the program listens. It takes what you type on the keyboard and brings it in. Looking back at our code, you can see this flow perfectly. First, cout makes the program talk, putting that enter your name message on the screen. Then cin into name makes it stop and listen, just waiting for you to type something. And whatever you type gets put right into our name box. And if you're curious, here's what's happening under the hood when it listens. When you type, your keystrokes go into this little temporary holding area. It's called a buffer. Then cin comes along, grabs those characters, converts them to the right type, a string in our case, and finally, it stores that value in our variable. So let's look at the whole thing one more time. It's not so cryptic now, is it? We create a box called name to hold text. We use cout to ask for the name. We use cin to listen and store the reply. And then finally, we use cout again to say hello, using the exact information we just stored. See? It's not a secret code at all. It's just a logical recipe. Now, this little program is perfectly fine all on its own. But what happens when you're working on a huge project? Something with thousands of lines of code, maybe written by a whole team of programmers. Things can get messy fast. Just imagine two different programmers on the same team both create a tool called print. When you try to combine their code, the computer's going to get totally confused. It'll have no idea which print you want it to use, and that can cause some serious problems. This exact problem actually has a name. It's called namespace pollution. It's what happens when common names from different parts of a project start to overlap and clash, causing conflicts and making the whole thing unpredictable. The solution is something called a namespace. And honestly, the best way to think of it is like a last name for your code. Our commands, count and sin, they belong to the standard or STD family. So that line at the top, using namespace STD, is just us telling the computer, hey, just so you know, for this program, whenever I use a command, assume I mean the one from the standard family. It's a simple way to prevent any mix-ups. So when you really boil it all down, that's what programming is. It isn't some kind of mystical art. It's simply the logic of creating these smart containers for information, our variables, and then laying out a clear set of rules for how those containers talk to each other and to us. And just for fun, how much can one of these little boxes hold? Well, one specific type of box that's made for whole numbers can hold a number this big. That's over 18 quintillion. Yeah, that is a lot of storage in one tiny little box. So there you have it. We've cracked the code on how to store information and how to have a real back and forth with a program. Now that you've seen these simple building blocks, the real question is, what's the first conversation you would want to start?